For the rational function, f of x is equal to negative 26x minus 104 over x squared minus x minus 30. Find the domain of the function. All right, so this function will be undefined if the denominator, which in this case is x squared minus x minus 30, is equal to 0. Now we can solve this equation by factoring. X squared minus x minus 30 factors as x plus 5 by x minus 6. And since that's equal to 0, that implies then that x plus 5 is 0, which means that x is negative 5. Or x minus 6 is 0, which implies that x is equal to 6. So there are two values of x for which the function will be undefined, and so for the domain, we must restrict the inputs so as to not include either of those values. So then the domain of the function can be written in several different ways. One way would be to write using the set builder notation, the set of inputs x, such that x is not equal to negative 5 or 6. Or we can write the domain using the interval notation. So from the real number line, we have to throw away negative 5 and 6. So we can go from negative infinity to negative 5, excuse me. And we'll use a parenthesis to say it goes right up to negative 5. And then we can go from negative 5 to 6. And then we can go from 6 to infinity. Part B asks us to solve f of x equals 3. We want the output, we want the function value to be equal to 3. So then we need to solve negative 26x minus 104 over x squared minus x minus 30 is equal to 0. No, sorry, not 0. We want it to be equal to 3. All right, so we have only one denominator in this equation, the x squared minus x minus 30. So what I'll do is I'll multiply both sides of the equation by that x squared minus x minus 30, multiplying on the right-hand side by the same quantity. That will clear the fraction on the left-hand side, leaving negative 26x minus 104. And on the right-hand side, applying the distributive property, I have 3x squared minus 3x minus 90. Putting this in a nicer form, let's get one side equal to 0. I will add 26x on the left and on the right. And I will add 104 on the left and on the right. So now I have 0 is equal to 3x squared plus 23x plus 14. All right, now we have to use some factoring to solve that equation. And using your favorite factoring method, this factors as 0 is then equal to 3x plus 2 by x plus 7. And so then, since we have a product of numbers equal to 0, we can set each factor to 0. So 3x plus 2 is equal to 0. Subtract the 2, divide by 3, x is equal to negative 2/3. Or, if x plus 7 is equal to 0, x is equal to negative 7. And both those values are okay. Neither of them are restricted from the domain. So it appears we have two solutions. X equals negative 2/3, x equals negative 7. Part C says to find the points on the graph at this function value. So this function value, what it's referring to, right, at this function value, well, that was the 3 from the previous exercise. And what we found was that if the output was 3, the x values, the inputs, were negative 2/3 or negative 7. So then the points on the graph at this function value, the points, would be negative 2/3, comma 3, and negative 7, comma 3. both of those points will be on the graph of that function.